Hey, continuing on with chapter 12 now, talking about probability. Today we're going to be talking about, or probability and statistics. Today we're going to be working on lesson 2, which is on permutations and combinations. Now, today's lesson is going to be made a lot easier if you have either a graphing calculator or one of these calculators like I have in my classroom, that both of them have the functions to be able to do what we need to do for today's lesson that will make it much, much easier for you. You can do the lesson if you don't have one, but it's going to require a lot more work from you. So first we're going to talk about permutations. When a group of objects or people are arranged in a certain order, the arrangement is called a permutation. So the key here is that they are arranged in a certain order. So for permutations, order does matter. So for permutations, the number of permutations of n distinct objects taken r at a time is given by the permutation of n, the number of objects, comma r, however many are taken at a time. And then we can use the equation n factorial over n minus r factorial. Then permutations with repetitions. So again, the number of permutations of n objects of which p are alike and q are alike is n factorial over p factorial times q factorial. So let's go ahead and walk through an example here. From a list of 20 books, each student must choose 4 books for book reports. The first report is a traditional book report, the second a poster, the third a newspaper interview with one of the characters, and the fourth a timeline of the plot. How many different orderings of books can be chosen? So, since each book report has a different format, order is important because it tells us the first is a traditional book report, the second a poster. If they just said you have to do these 4 projects, doesn't matter what order, then that would be a combination, which we'll get into on our next slide. But since the order does matter, this is a permutation. So we must find the number of permutations of 20 objects taken 4 at a time. So this is where we would set up the permutation of 20 objects, comma, we have to take 4 at a time. So then we would do 20 factorial over 20 minus 4 factorial. And how we can think of this is 20 factorial, again, is 20 multiplied by every number smaller than itself, all the way down to 1, over 16 factorial, so 16 multiplied by every number smaller than itself, all the way down to 1. Now you see here, we can cancel out the 16 and everything smaller. So this would just become 20 times 19 times 18 times 17. So this is where if you don't have a calculator that can do factorials, you can still do this problem, you just have to plug in extra numbers. The other way you could do this is instead of having to think of it like this, we know that it's 20 factorial over 16 factorial. So I'm actually going to show you 2 different ways that you can think about this. The first one, so on our calculator, the first way that you can think of this is just as plugging it in as division on your calculator. So you would do, I'll show you on both of these calculators. If you've got your graphing calculator, again, for that factorial, we would go 20, and then factorial, you go math, over to probability. Then you can either go down to that 4th option, which is the exclamation point, or you can just press 4. And then we're going to divide that by 16. Again, factorial, so 20 factorial divided by 16 factorial gives us our solution of 116,280. Same solution we get right there. Now, if you're using this calculator, you would go 20, then you would press the probability button and go over to the exclamation point. So 20 factorial divided by 16, again, probability, go over to the exclamation point. So 20 factorial divided by 16 factorial, again, gets you that same answer. So that's one way you can think of it on the calculator. The other way is, if you see here when we press math and go over to probability, that second option right there has NPR. So what that is when we have this, the permutation of N comma R, N is 20, R is 4. So the other way we can do this on our calculator is if we put in 20, then press that NPR button, and then put in 16. Because 20 is our N, the total number of objects. R would not be 16 in this case. Sorry about that. R would be 4, because we're taking 4 at a time, that R value. So again, on our graphing calculator, we would go ahead and press 20, then we'd go to math, over to probability. Again, you can go down to NPR and press enter, or you can press 2 since it's the second option. So you've got 20p, and then our R value was 4. Press enter, gives you that same answer right there. If you're using the other style calculator, same thing, we're going to plug in 20. You're going to press that probability button. You want to have NPR underlined. Then you're going to put in a 4, press enter. We get that same answer. So I know this is kind of spending a long time on one example here, but I want to show you all the different ways that you can come up with this. The awesome thing about these calculators, especially graphing calculators, for problems like this, it already has the whole formula programmed into your calculator. All you have to do is plug in a couple numbers and you'll get your answer. So, for evaluating each expression, if we have the permutation of 6 objects taken 3 at a time, long way of doing this, we can write it out as 6 factorial over, again, remember, it would be n minus r factorial. So n would be 6 minus r, which is 3. Again, first number is your n, second number is your r factorial. So that would become 6 factorial over 3 factorial, which then the 3 and smaller cancels itself out, so this would become 6 times 5 times 4, which would give us 120. Again, we have 2 other options on our calculator. You could either go 6 factorial divided by 3 factorial, which gives us that answer of 120, or we can press 6, go over to probability, go to the permutation function, and then press 3, and again we get that answer of 120. So for 2 through 4, I'm going to go ahead and just use that permutation function on my calculator. So for this one, again, that first number is my n, second number is my r. So 8, go over to NPR, plug in 5, I get 6,720. So that's how we can solve those. Now again, if you wanted to set this one up with the factorials, that would become 8 factorial over 8 minus 5 factorial, or 8 factorial over 3 factorial. And then again, you could just plug that in as a division problem on your, you could do 8 factorial divided by 3 factorial. So, if you're wanting to do the division, you need to set it up in that n factorial over n minus r factorial to figure out what that bottom one will be. If you're going to use that NPR function, all you need is the original numbers that they give you. Now, how many different ways can the letters of each word be arranged? So this is where we're going to use this second one, the permutations with repetitions. The number of permutations of n objects, so the total number of objects of which p are alike and q are alike, is n factorial over p factorial times q factorial. Now this one, it could just be n factorial over p factorial if you only have one thing that is alike. So for this, the word mom, how many different ways can the letters be arranged? We have 3 total letters, so we would have 3 factorial over how many of them are repeated. The m is repeated, and it's repeated twice, so it would be 3 factorial over 2 factorial, which in this case would be 3 times 2, which is 6, over 2 would give us an answer of 3. For number 6, the word Monday, we have 6 total letters. None of them are repeated, so it would just be 6 factorial, which if we plug that into our calculator would give us 720. And then the word stereo, there are 6 total letters, so 6 factorial over, the E is repeated twice, so over 2 factorial. And if you plug that into your calculator, 6 factorial divided by 2 factorial, you would get 360 possible solutions. And then the story or the word problem here. The high school chorus has been practicing 12 songs, but there is time for only 5 of them at the spring concert. How many different orderings of 5 songs are possible? So in this one, because the order matters, how many orderings of 5 songs, we're going to have the permutation of n, the total number of items, which is 12, comma r, which is how many of them are selected at a time, which is 5. We're selecting 5 songs at a time. So again, 2 different options here if you're using your calculator. You can do 12 factorial over 12 minus 5 factorial, which would give you 12 factorial over 7 factorial. Or, if you want to just use that permutation formula, which is already programmed in your calculator, you would plug in, again, first one is your n, second one is your r. So you would do 12 NPR and then 5, which either way, you would get a solution of 95,040 possible ways to order 5 of those 12 songs. So that's permutation. Again, that's when the order does matter. Next, we get into combinations, which is an arrangement or selection of objects in which the order is not important. So here, our formula that we're going to use looks very similar, except that once we've done, so we have n factorial on the top, the total number of objects, over the number of objects minus the number taken at a time factorial, and then you need to multiply that denominator by the number taken at a time again, because the order does not matter here. So for this example, how many groups of 4 students can be selected from a class of 20? So since the order of choosing the students is not important, you must find the number of combinations of 20 students taken 4 at a time. So here again, instead of the permutation of n comma r, we have the combination because the order doesn't matter. And we have 20 total, comma, the number taken at a time, which is 4. So plugging it into our equation, 20 factorial over 20 minus 4 factorial times 4 factorial, which would then become 20 factorial over 16 factorial times 4 factorial, 4,845 possible ways. So here, again, two different ways of being able to do this on our calculator. The first way, I'll write this up here again. The first way is once we got to, oh, sorry, I didn't want to do it there. I'm going to do it up on the first example. So the first way, once we've gotten to this step right here, you would do that 20 factorial divided by 16 factorial times 4 factorial. Now, an important note here. When you're doing it on your calculator, when you're plugging it in, you can't just plug in 20 factorial divided by 16 factorial times 4 factorial, because in your calculator order of operations, once we're down to multiplication and division, it just goes left to right. We have to have that multiplication done first. So two options. You can either do, for this one, you could do 16 factorial times 4 factorial. And then do, let's see, 20, wait. Okay, sorry, yeah, 16, no, okay, what we want to do here, sorry for the confusion, what you want to do here is you want to use parentheses in order to solve this. So you want to go 20 factorial divided by, and since we want that multiplication to be done first, if we put that in parentheses, thinking order of operations, whatever is in parentheses will be done before the division. So we would go 16 factorial times 4 factorial end parentheses. That way it'll do the multiplication first and then divide it, and we get that same answer of 4,845. So on your calculator, you want to make sure that is in parentheses. Now, the other way you could do this on your calculator, just like we had that NPR symbol, there's also one that says NCR, where you just need to look at those numbers right there, and you would plug in 20 NCR and then 4. So let's take a look at some examples here. We're finding the combination of 5 total objects taken 3 at a time. Again, two different ways of doing this. We could go 5 factorial, the total number, over the total minus the amount taken at a time factorial, over r factorial. So that would become 5 factorial over 2 factorial times 3 factorial. Or you could plug in 5 NCR, and since your R value is 3, you would plug that in. Either way on that one, we would get a solution of 10. And then same thing on number 2. We could go 7 factorial over 7 minus 4 factorial times 4 factorial, which would give us 7 factorial over 3 factorial times 4 factorial. Or you could say 7 NCR 4. And again, either way, you're going to get the same answer, which in this case will be 35. So if we take a look at number 5 then, from a standard deck of 52 cards, in how many ways can 5 cards be drawn? So if we think about it here, we're finding the combination of 52 total items and 5 being taken at a time. So I could go ahead and say 52 factorial over 52 minus 5, which would be 47 factorial, times that r value, which would be 5 factorial. And if I were to plug that in, I would get my solution of 2,598,960 possibilities. Again, I could also plug this in as 52 NCR 5. If you're doing it this way, setting up the equation, the two numbers in your denominator should always add up to equal whatever your numerator is. Number 6, how many hockey teams of 6 players can be formed from 14 players without regard to position? So the key here, without regard to position, tells us that we're going to be using a combination because the order does not matter. Now, when you're doing your homework, it's not going to be equally split up of permutations on this one, combinations on this one. You're going to have to look for those key words to see which one you need to use. So here, we know it's a combination of 14 total players taken 6 at a time. So we could say 14 NCR 6, which would give us a solution of 3,003 possible combinations. And then the very last one, number 7 here. This one is a little bit more tricky, and I'll explain why after I read the problem. From a group of 10 men and 12 women, how many committees of 5 men and 6 women can be formed? So here we actually have 2 different combinations that we need to come up with. We can't just add this up and say that there's 22 total people and that we need to pick 11 of them, because we've got separate for men and women. So I'm going to go ahead and split this up into 2 separate combinations. The order doesn't matter, so I know they're combinations. For the men, we have 10 total, and we're taking 5 at a time. So again, we could plug that in as 10 NCR 5, or we could say 10 factorial over 10 minus 5, which is 5 factorial, times r, which is 5 factorial. Either way, we would get a combination of, we could have 252 possible combinations of men. Now for women, it would be a combination of 12 total, taken 6 at a time. So same thing, we could go 12 NCR 6, or we could go 12 factorial over 12 minus 6, which is 6 factorial, over r factorial, which is 6. Either way, we'll get 924. So we know for the men, there's 252 combinations. For the women, there's 924 combinations. Now the last thing we need to do is going back to Tuesday's lesson about the counting principle. We know that we have that many different combinations of each one. Now we have to multiply those by each other to figure out the total number of combinations to pick 5 men and 6 women, which would be 232,848. Now I know I walked through this fairly quickly. Feel free to go back, pause, rewind, do whatever you need to do. Look through the notes as you're following along with the video, and feel free to reach out if you need any help. I did forget to include what the homework is going to be here. The homework will be the worksheet, which is online. And again, feel free to reach out with any help you might need, and please make sure you're getting any missing work that you might have into me in the next week or so that you can get that grade as strong as possible going into your final.